Hello viewers, welcome to another interesting lecture of digital signal processing. In this segment, we are going to discuss discrete signal operation. This lecture is totally conducted by Ganon, powered by Wishback. I am your mentor, Professor Auritrodev. So, let us start our discussion today. Signal processing or operation is a group of basic operation applied to an input signal, which result in another signal as output. The mathematical transformation from one signal to another can be represented by yn is equal to capital T of xn. This is the basic of the signal operation. Now let us discuss the basic set of the signal operation. They are shifting, time reversal, time scaling. It may be scalar multiplication, maybe signal multiplication or signal addition. Now let us discuss each operation one by one. First, we are going to discuss the shifting operation of the signal. So, the shift operation takes the input sequence and shifts the values by an integer increment of the independent variable. The shifting may be delay or advance the sequence in time. Mathematically, it can be represented by yn is equal to xn minus k, where xn is the input and yn is the output signal. Now, if k is positive, the shift delays the sequence. On the other hand, if k is negative, the shifting advances the sequence. A signal xn is shown in the figure. The signal x minus 3 is obtained by shifting xn right by 3 units of the time. Also, the signal xn plus 2 is obtained by shifting xn left by 2 units of the time. Now let us discuss the time reversal operation of the signal. Time reversal of the sequence xn can be obtained by folding the sequence about n equal to 0. It is denoted by x of minus n as shown in the figure. The signal x minus n plus 2 is x minus n delayed by 2 units of the time. On the other hand, x of minus n minus 2 is x minus n advanced by 2 units of the time. Now let us discuss the time scaling operation on the signal. xn is a sequence as shown in the figure. If lambda is equal to 2, then a new sequence of xn can be generated. Let us discuss them. Say yn is equal to x of 2n. The plot of the sequence can be generated by for n equal to minus 1. Observe very carefully. For n equal to minus 1. In this case, y of minus 1 is equal to x of minus 2 is equal to 3. And for n equal to 0, in this case, y0 is equal to x0, which is equal to 5. And for n equal to 1, y1 is equal to x2 is equal to 3. Also, for n equal to 2, y2 is equal to x of 4 is equal to 1, and so on so forth. From that result, it can be concluded that to plot yn, odd number of the samples in xn is skipped and retain only even number of the samples. Now let us discuss another sequence y dash n, which is equal to x of small n divided by capital N. Let us consider in this case capital N is equal to 2. Therefore, y dash n is equal to xn by 2. Now observe very carefully. If you put the values of the n, how it will be changed. For n equal to minus 2, what happened in this case? In this case, y dash minus 2 is equal to x of minus 1. For n equal to 0, y dash 0 is equal to x0. For n equal to 2, in this case y dash 2 is equal to x of 1. For n equal to 4, y dash 4 is equal to x of 2. And for n equal to 6, y dash 6 is equal to x of 3, and so on so forth. Y dash n is not defined for odd values of n. Therefore, it can be assumed that y dash n is equal to 0 for odd values of n. Now, if the delay k is k equal to 1, we get a unit delay element that delays the signal by one sample. If the input signal is xn, the output is xn minus 1. In fact, the sample xn minus 1 is stored in the memory at n minus 1 and it is recalled from the memory at time n. Therefore, it formed yn is equal to xn minus 1. Thus, these building blocks require memory. If delay k equal to minus 1, we get an unit advanced element. Now let us discuss scalar multiplication. A scalar multiplication is as shown in the figure. Here the signal xn is multiplied by scale factor small a. Let us discuss one example. Say xn is equal to 1, 2, 1, minus 1 and small a is equal to 2. Then the signal a into xn will be 2, 4, 2, minus 2. Now let us discuss signal multiplier. In this case, the multiplication of the two signal sequence is done to form another sequence. Let us take one example. If x1n is equal to minus 1, 2, minus 3, minus 2 and x2n is equal to 1, minus 1, minus 2, 1. So, in this case, x1n into x2n is equal to minus 1 into 1, 2 into minus 1, minus 3 into minus 2, minus 2 into 1. So, what is the result? Result is minus 1, minus 2, 6, minus 2. Now, two signal can be added using an adder. If x1n is equal to 1, 2, 3, 4 and x2n is equal to 4, 3, 2, 1. If you perform the addition among these two sequences, then x1n plus x2n is 1 plus 4, 2 plus 3, 3 plus 2, 4 plus 1. So what is the result? Result is 5, 5, 5, 5. So what we have discussed in this lecture? In this lecture, we discussed shifting operation on signal. Then we discussed time reversal operation on signal. After that, we discussed time scaling operation on signal. Next, we discuss scalar multiplication and signal multiplier operation. After that, we discussed signal addition. That's all for this segment. I urge you to practice each operation individually. Take any arbitrary signal, perform the operation on that type of the signal. Thank you, viewers. Bye.